Hey my dear lovely students, a very good morning to all of you. Once again, I'm in front of you for the live video session of the last topic of integers, that is the properties for the division of integer. I hope you all are studying sincerely at your home and following all the instructions being provided by your respective teachers. So without wasting time, let's straight dive into our today's video lesson for the properties of division of integer. So let's start. Properties of division of integer. Properties of division of integer. Like we have discussed the properties for addition, subtraction and multiplication, the same method we will follow in this particular topic, that is properties for division of integer. The first property which we are going to study is closure property. I hope you all are very much aware with this property. What was closure property? In addition, we studied that if the sum of two integer is always an integer, this means that it follows closure property. In subtraction, we studied that the difference of two integer is always an integer. In closure property for multiplication of integer, we studied that the product of two integer is always an integer. But now in division, what we are going to study in closure property, that it is not necessary that division of two integer will always be an integer. So division of integers do not follow closure property, or it may follow sometimes. This will be very much clear with an example. For example, suppose we have two integers. A and B, where A is equal to 5 and B is equal to 2. So we are studying division. So A divided by B will be equal to A equal to 5 divided by B will be equal to 2. What will be 5 divided by 2? Nothing. It will be in the fraction form, that is 5 by 2, or can be expressed in the form of decimal form 2 by 5. And what we have studied in integer, that any positive or negative numbers are known as integer. Integer do not comprise of fractional number or decimal number. So here we can easily see that the division of two integer is not closure. Let's see one more example. This was example 1. One more example. Let A is equal to 6 and B is equal to 2. Now we can divide A divided by B. So A will be equal to 6 divided by B divided equal to 2. 6 divided by 2 will be equal to 3. 6 divided by 2 will be equal to 3, and this 3 is a positive integer. That is why I am saying that it is not necessary that division of two integer will always be an integer. Here it is an integer, but in this particular case it is not an integer. It is of the form decimal form or fraction form. So this depends on the type of integer we have. So the closure property for division of integer states that if we divide two integer, it may be closure or it may not be closure. Let's move on to next, that is commutative law. Once again, an important property. What is commutative law? Like we have studied in addition, subtraction and multiplication. If we interchange the positions of two integer, it does not change the integer. That is, if 2 plus 3 will be equal to 5, likewise 3 plus 2 will also be equal to 5. So what we are going to study commutative law for division of integer. It also do not follow commutative law. The division of two integers, the division of two integers is not commutative. Is not the division of two integers is not commutative except when both the integers are same. Division of integers do not follow commutative law, but it will follow commutative law when both the integers will be same. Let's take this with an example. Let two integers be a and b, where a is equal to 6 and b is equal to 3. So commutative law, that is a divided by b. A will be equal to 6 divided by b will be equal to 3. What is 6 divided by 3? It is equal to 2. And b divided by a. What is b? 3 divided by a. What is a? 6. 3 divided by 6 will be equal to 3 upon 6, that is 1 by 2. And we can clearly see that this 2 is not equal to 1 upon 2. They both are not equal. Hence, a divided by b is not equal to b divided by a. Hence, division of integer is not commutative. But let's take us one more example where both the integers are same. Let a is equal to 5 and b is equal to 5. Then a divided by b, a equal to 5 divided by b equal to 5. 5 divided by 5 equal to 1. Again b divided by a. b will be equal to 5 divided by a equal to 5. 5 divided by 5 will also be equal to 1. Hence they both are equal. Let's take one more example where a is equal to 6, b is also equal to 6. Then a divided by b, 6 divided by 6 will be equal to 1, and b divided by a, that is again 6 divided by 6 will be equal to 1. Hence we can see that the division of integers follow commutative law when both the integers are same, and both the integers are different. Division of integers do not follow commutative law. Let's move on to the next property, that is associative law. That is also an important property. Associative law for division of integer. Associative law for what we have studied in associative law, that it is applicable for 3 integers. So for any 3 integer, for any 3 integer a, b and c, the division of integer is not associative. Division of integer also do not follow associative law. This means that, this implies that a divided by B divided by C is not equal to A divided by B divided by C. But one thing which is worth mentioning is that division of integers will follow associative law. The division of integer follows associative law when the magnitude. What is magnitude? Magnitude means value. When the value of C is 1. So the only condition where the division of integer follow associative law, is when the value of C will be equal to 1. If the value of A, B and C are different and C is not equal to 1, then division of integers do not follow associative law. Let us take an example. Let A is equal to 6, B is equal to -4 and C is equal to 2. Let's solve LHS part. That is A divided by B divided by C. And then RHS part, that is A divided by B divided by C. So first of all we solve LHS part. A, what is A? 6 divided by B. What is B? -4. We'll put a bracket over here because we have two signs together. Divided by C. What is C? C is 2. So we can solve it. 6 divided by -4 divided by 2. 6 divided by -4 can be written as 2. 3 is a 6, 2 2 is a 4. 3 by 2 or -3 by 2, and divide will change into multiply, and 2 will be equal to 1 upon 2. So what will be the result? 3 1 ja 3, 2 2 ja 4, and minus sign will retain. That is -3 by 4. Let's solve the RHS part. A, what is A? 6 divided by B. What is B? -4 divided by C. What is C? 2. 6 divided by -4 divided by 2 can be written as -4 by 2. 6 divided by -4 divided by 2 will be equal to 2 times, that is -2. And 6 divided by -2 can be written as 6 over -2. And 2 will divide 6 in 3 times, but the minus sign will retain, that is -3. So what we can see is in the LHS we have -3 upon 4, and in the RHS we have -3. That is LHS is not equal to RHS. Hence A divided by B divided by C is not equal to A divided by B divided by C. Let's take one more example where the division of integer is associative. Example 2. Let A is equal to 6, B is equal to 3 and C is equal to 1. So first of all we'll solve LHS, that is A divided by B divided by C, and then we will solve RHS, that is A divided by B divided by C. A, what is A? We have A equal to 6 divided by what is B? B is equal to 3 divided by C. What is C? C is 1. 6 divided by 3 can be written as 6 over 3 divided by 1. What is 6 divided by 3? 2. 2 divided by 1 can be written as 2 multiplied by 1 upon 1, or simply 2 will divide 1, that will always be equal to 2. Let's solve the RHS part. What is A? A is 6 divided by B. What is B? 3 divided by C. What is C? 1. 6 divided by 3 divided by 1 will again be equal to 3. And what is 6 divided by 3? That is 6 over 3. What we get? 2. Thus we can see that in the LHS we have 2 and in the RHS we have 2. LHS is equal to RHS. Hence, A divided by B divided by C is equal to A divided by B divided by C only when C is equal to 1. I hope it is clear to all of you. Let's move on to the next property, which is also an important property. You'll have to learn these all properties. Fourth, if A, B, C are non-zero integer, A, B और C जो है वो एक non-zero integer है. This means that they are not zero. Their value can be anything but not 0. A, B, C are non-zero integer and A is always greater than B. A is always greater than B. Then what is the first case? What is the first case? If we divide A divided by C, will always be greater than B divided by C when C is positive. अगर आपके पास A, B, C तीन नॉन जीरो इंटीजर है जिनका वैल्यू 1 नहीं है और A का वैल्यू जो है वो हमेशा B से बड़ा है, तो जब भी हम लोग A को डिवाइड करेंगे C से तो उसका वैल्यू बड़ा होगा जब B डिवाइडेड बाई C होगा. That is A divided by C will always be greater than the B divided by C, and this condition only implies when C is positive. So let's take an example over here. We have to take A greater than B. So let A is equal to 6 and B is equal to 4 and C is positive. Let C is equal to 2. Let's solve. A divided by C. What is A? 6 over 4. 6 over 4 is always greater than B divided by C. What is B? 4 divided by C. 2. What is 6 over 4? What is 6 over 4? That is 2 3s are 6, 2 2s are 4. And what is 4 over 2? That is 2. So we can see that A divided by C is greater than B divided by C. A is 6 and what is C? C is 2. Is greater than B divided B is 4 and C is 2. 2 over 6 will be equal to 3, and what is 4 over 2 will be equal to 2. Thus we can say that 3 is greater than 2. Hence this condition is